Hi everybody and welcome to GOTO Unscripted, live from Chicago. My name's James Beswick and I run developer relations at Stripe, and here I am with Ben.
Hi, I'm Ben. I'm a staff developer advocate at Stripe.
So we had a few things we wanted to chat about that we've actually been talking about for a while. And Ben, you've been doing a lot of work over the years in workflows. And I think one of the questions that people don't think about is, why do you need a workflow to begin with?
Yeah, it's kind of almost counterintuitive for a developer, right, to say code less and do workflows more. But there's so many good reasons why you would do this, in my opinion, right? The first is that if you're building out things in workflows, there's literally less code to manage, okay? And I'm talking about workflows where it's not necessarily something that you've built using an SDK, you know, something where you have a interface that you can drag and drop and build out a state machine. So the first thing is there's less code to manage, essentially. The second is that not all, but many of these workflow services are pay per use. They're serverless in nature, right? So they scale automatically. They grow with your business in terms of the cost of them. Another good reason would be the way that you're able to decouple these workflows from other workflows to create microservices, which we can chat about a little bit more later on. But like, what would you say is a really good reason to use workflows?
Well, I was thinking about some of the difficulties when you're in distributed systems of handling issues like idempotency. So when you've got a problem where maybe due to a network issue, a message didn't arrive, how do you know on the receiving side you're not handling something twice? And it seems like workflow implementations are a really good way to handle this type of really sticky problem. Or on the other side of it, that handling something like an error when something goes wrong and you've got a custom flow, we need to back out and cancel things in a certain way. And when I look about some of the things you built, for example, you were famous at AWS for building serverless espresso.
Right.
And at Stripe, you're building similar things like that.
Yeah.
But you get into these very sticky problems with workflows that you found really interesting use cases for.
Yeah, interesting is the word. I wouldn't say that. So actually, I have done a bunch of talks where I've said you should use step functions, which is the AWS tool for building workflows. I used to say you should use them always. And in hindsight, I would roll that back a little bit and say you should probably start with deciding why you wouldn't want to use a workflow. And I think it's a really good solution for most kind of microservices where you need to run a series of APIs or a series of discrete pieces of code, maybe in Lambda functions, in response to certain events. And because you have this way of very visually being able to orchestrate, branch on if statements, create these loops, you can create circuit breaker patterns, you can create catch and retry patterns, pretty much everything that you learn about or everything that you would build in code, you can visually represent as a workflow. So I think that's another really nice reason to use workflows. And what you say as well, you can put configuration into your application rather than adding extra code, right? So you can catch errors, you can retry errors, you can send those errors downstream to other queues or services to handle them. And it's all very visual when these things go wrong, so you can inspect them nice and easily.
So I'm going to ask a question that I suspect many people want to ask, but everyone's a bit afraid. What is the circuit breaker pattern?
The circuit breaker pattern is a way of preventing you from constantly calling a downstream service that you know to be faulty. So if you imagine this in a workflow, you would have something where you check the overall status of your circuit or your application. And if it's good, you go ahead and you do the things that your application needs to do. If the next execution that comes in realizes that, hang on, there's a problem, and the problem is something that you've caught with a previous error, right? So you have a workflow. If something errors out, you catch that error, you update the status of the circuit to say, okay, this is now bad circuit, this is broken, we don't want to keep calling these downstream services. Especially if there's something in the cloud where you're paying every time you're trying to call that, right, normally. So with your circuit breaker pattern, you query the status at the beginning of the execution, and if it's known to be broken, you do some kind of escalation path, and if it's not broken, you can continue executing on the happy path, right? So it's essentially stopping you from continually calling those services that you know to be bad.
What's really interesting though is these things are very, very hard to build by yourself.
Yeah.
I mean, if you're trying to build that type of logic just off the bat. This is really hard to get right and to test. And so I think one of the interesting parts of workflows is when you look at real life enterprise development, it's full of these kinds of things that tend to be really awkward, but can be encapsulated really very easily within workflow software.
Yeah, that's exactly right. You can literally, imagine a typical developer is building lots of things all the time. They're context switching, even hour to hour, let alone month to month. And if you have something like a circuit breaker pattern that maybe something's gone wrong or it's broken, you can open that up in a workflow months later and instantly understand where it went wrong and that, okay, this is some sort of circuit breaker that I've built. If that was written in code, I think it would take most people a lot longer to kind of reason about what it is they've built and where it went wrong, right?
And actually, when you and I have been building things together, what often you don't see in demos and hello world examples and tutorials is the fact that real life is full of versioning.
Yeah.
That you might get your business case down and it works for today, and then 6 months from now, you suddenly find there's a change in the process you have to update. And again, in software, if you build this yourself through your own code, you become very hesitant to want to change that code. It gets fragile because everybody's relying on it, and it's very hard to do that version 2. Tell us a bit about how you would look at doing versioning with this type of approach.
There's a few different ways, right? You can have a way that you kind of do canary deployment, so that you check that the new thing that you've built is working by sending like a smaller amount of traffic to it at first, and you can catch problems with that and then roll back effectively. You can tag things with version and have your own kind of form of version control. I don't know, I think it's kind of specific to what you're building, the team you're working with, and the tools that are available to you, right? I know when we were building Serverless Espresso, we would come in to the room every morning and redraw the workflow and try and understand what's happening and how things are connected. So even if you're doing things as a workflow with a visual builder, these things are still difficult, right? They're still hard to get your head around because there's so many disparate pieces. It's kind of an issue with building with microservices in general, I think.
And I think when you have Serverless Espresso is a good example because it's an ordering process where various things have to happen in a sequence or they get unwound. It gets really interesting when you add something like payments because many things you can make mistakes on. Payments you cannot. If you accidentally do something, you can charge a customer twice or not at all, or something else goes wrong, and you burn that trust with the customer. And so with payments, the actual fact you charge someone or don't charge them is something you've got to get right every single time, and it doesn't matter if you have millions of transactions, it still has to be right, each time. So when you think about idempotency, and this is something we don't actually discuss enough, but how can idempotency be bundled in these workflow services in a way that makes it easy?
Well, first of all, we should explain idempotency, right? Because it's one of these weird words that you only really hear in terms of computing. So my interpretation of idempotency is that if you provide the same input, you should expect the same result every time. Is that like a nice simple way of explaining it? So your question was, how can you implement idempotency in workflows? There's a few things you can do. The first is that you can have a literal idempotency ID to make sure that you know each execution and that pertains to a certain result, and so that you don't reproduce different results with the same idempotency key. What else would you say would be a good way to handle that? I think,
certainly the IDs and the way you use those and track them through is important because use something like DynamoDB to keep track of these keys. Have you seen them before? So you don't need to do this. Some services do just build idempotency in if you provide IDs, and that's useful. But I think also there's a state of mind, and that's assuming that the provider doesn't just do it for you, or that there won't be this problem. Because I think in testing and in small numbers of volumes and small batches, these problems often don't come up. But when you look at millions of transactions, these long tail problems are a part of the reality that you're going to start to see these issues arrive. So I think as long as you think about them and plan them in and use services in the way where they're supported, you can approach it the right way. But it's amazing how many customers we've dealt with and talked to where it's just assumed there won't be a problem.
This is kind of a challenge with being a developer advocate as well, is that you build applications that are often fairly small in scale. You try and build them for scale, but Serverless Espresso, for example, is probably the most used application that we would have built as a DA, and that's had maybe 100,000 users go through it in total. This is not a massive thing, right? There's not hundreds of thousands of events happening every day on this. So you don't always come across these edge cases, right, that customers are coming across. So it's a bit of a challenge with the role, I think.
Yeah, and when we tested the workflow for Serverless Espresso, we used that bot where we were testing for 1 million orders a day to see what would happen, where the breaking points were.
Right.
But of course, the application would never see 1 million orders in cups of coffee through a conference. But it's worth doing that kind of testing to see where the weird behaviors start to happen.
Yeah, good point. That was a good plan, actually, to use the scalability of the workflow service to test itself in a sense, right? Yeah, that was probably the closest we could have come to simulating a real event.
Yeah. But I think, with the workflow approach, it's not just step functions. There are other services like temporal. There's a variety of different options. Yeah. And I think it's just, as a concept, it's underused.
Yeah.
That when I think about what people are building out there, there's still too much building yourself when you could just pull a service in to do a lot of this complexity for you.
I think it's just the way developers are built as a persona, right? You're problem solvers. So you see a problem, you think, I can just write something to do that. But it's a mind shift to allowing you to use something else, that a whole team that are dedicated to just that one service, right? Whether that's payments or whether that's serverless or observability, to just pull in the API that team are offering you can sometimes save you so much time in the long run and offer you so much more power than you as a developer solving that on your own.
Yeah.
Right?
And I think I've been doing software for 25 years, I guess, and one of the big things I think that's changed is that back in the day when I was a C++ programmer writing things on a trading floor, they're all running on one machine in the same memory space, using a hard disk. Nothing's really going over the network. And that masks a lot of problems. You don't tend to see race conditions or other things. And now with the adoption of cloud and all these services in the way, these problems are unavoidable. And as you're going towards distributed computing, you're suddenly now dealing with networks where things go wrong and things don't always happen in a sequence in the way that you expect. And so I think the planning is a lot harder when you're putting these types of apps together.
Definitely. And you don't always have the expertise in every field that you need to know, right? I think the most successful customers that I've seen are those that pull in the best of breed, right? So they'll have maybe 1 or 2 cloud providers using the best of both. They'll have something for payments, they'll have something else for their observability piece. And then the bit in the middle is their secret sauce. That's the value or the unique thing that their application does that no other can do, but pulling in these other APIs and these other services as microservices, right? I mean, what do you think when you look at the progression of kind of monolith to microservice, potentially now back to monolith? We're starting to see a little bit. It seems to be a weird wave and a weird point of that we're on now.
Yeah, I think the microservice design has been confusing for the community generally because there's always this question of how big a microservice should be. And obviously it depends on the organization and the team size and what you're building and all sorts of variables that are hard to come up with absolute rules. But often you would see microservices that are just way too small or way too big. And when I come out the other side of that, I think there are some things you can say that you shouldn't build yourself. I mean, Auth is one of these things where you've got services like Auth0 that do this for you very well.
Right.
And the cloud providers have similar services. But the one thing you can say with certainty is you shouldn't roll it yourself, that it's one of those dangerous things. If you get it wrong, you're going to get hacked, you'll lose data, you'll lose trust. And it's the same with things like payments. Credit card numbers are effectively toxic. So why allow them in your application when you can easily farm out that work to a provider to do it for you? But the services in the middle of how you then model your own business logic are still a bit open to interpretation, and the size. I think the move towards the monolith again is actually just probably microservices getting big once again.
Right. There's an interesting train of thought as well that a workflow in itself is a kind of monolith, or a state machine is a monolith, right? Because you have this enclosed area where the workflow only really knows about what it knows within that execution history, right? And the more things you drag in and orchestrate, the more this workflow grows, and eventually you can very quickly, accidentally, build a monolith as a workflow. I mean, what are some of the things that you've seen customers do to get around this problem of accidentally building a monolith?
Yeah, I think, and it happens over and over in different ways, doesn't it? Where I think it's easy with microservices to over-orchestrate what goes on between them, and you accidentally create this very fragile glue between everything.
Exactly, yeah.
And so one of the reasons I really liked EDA as a concept, event-driven architecture, was that it forces that apart a little bit. But even then you can get to similar problems where this question of whether you use very thin events or you use very large events can cause this flow where actually just the flow of events causes the monolith.
So what's an example of a thin event then?
Yeah, if you look at an e-commerce app, an event where you say an order ID is number 2,
right.
But a fat event, the opposite, would be the order ID is 2 and the order contains a cappuccino, it's for Ben and it's this type of milk and here's the currency.
Right.
And you really put everything you know about it into that. And somewhere in between the two is usually the right place to be.
So in the thin event version, presumably you would store the rest of the info in some quick lookup that you can access. Okay.
And that in itself is a problem, because then each downstream service might well be pinging that service to find out what the overall state of order number 2 looks like. And so it can get overwhelmed by the number of requests, or you just got a lot of traffic going backwards and forwards.
And then each downstream service needs the authorization to access that resource to get the more information. And so where does that sit, right? So maybe you build that into the workflow piece and then you're back to your monolith again. So I think you're right though. I think events is one great solution to decouple these services, especially with workflows, right? So you use your workflow piece to orchestrate within some sort of microservice boundary. You have to draw that boundary eventually at some point. And then I think it's normally within a certain domain, right? You can normally understand the domain. Like this domain is the thing where I'm ordering drinks and I've got a database to keep track of the orders and I've got a workflow to orchestrate how those orders change. Right. And then I've got something else, which is maybe the customer microservice and an API to update customer info and a customer database. And these might want to communicate with each other by consuming and producing events. And in the middle of that, you have some sort of notification service or event bus or something like this.
But I think a lot of this design choice, however you build these things, the computers and the servers and the systems behind them will support it and it'll work just fine, mostly, generally speaking. The real design choice comes down to the cognitive load you want to put onto your team.
Right. Yeah.
Because when I think back through jobs I've had in the past where you build things, the monolith tends to require developers to know way too much about what's going on. It makes onboarding new developers hard. It makes it hard to make changes to systems. And so really these types of designs are all about how can you reduce the amount of knowledge you need about each service. And more importantly, when you come back 6 months from now and you don't remember what you built, how quickly can you onboard yourself to a design so you can make changes to it?
I think this is the challenge with things like Lambda as well, because there's a lot for you to learn up front before you can even start dropping code into your Lambda function. Or you could say, it's a similar problem with something like SAM, which is the serverless framework for uploading applications on AWS, or serverless framework itself, right? These are all things that have a big cognitive overload for you to learn before you can start adopting it. Whereas something like CDK, for example, AWS CDK, is a more similar framework for building, for coding. So I think these services where they are meeting the developer where they are, they're using the languages that developers are already using, they're using terminology that we're already familiar with. These are the things that seem to be a lot more successful, right? Yeah.
A lot of the work you did on extensions and extensibility, I think is again underused in the community as a concept, because people are always trying to build the one application to rule them all, where basically the thing that covers every use case, and every time a new feature comes in, you're kind of just assuming it into the code base. And to me, this is not the way to go. You just increasingly create a blob that is unmaintainable and just over time starts to atrophy. And whereas extensions, I think, can be really powerful. Actually, tell us a bit about extensions, because that was just something extraordinary that you built.
For the serverless video stuff?
Serverless video.
So, this was a concept that we wanted to create where we would create an application that allowed you that would do a core functionality. So take an example of a live video streaming app, right? And we would build the core functionality, but what we wanted was to allow people to extend that core functionality. And the way we wanted them to do that was by consuming events. And these events are fired off important milestones along the post-production workflow of this live video stream. So a video is streamed, the video ends, and after that, there's an automated post-production workflow that does things like translates the video or generates captions or works out who was in the video, for example. And we wanted to create events that would occur along these different, this workflow, and to publish these events, and for developers to be able to say, oh, well, I'm interested in when the captions file has finished generating because I want to make an extension that will translate the captions into Spanish. So they could hook in to the event that would say something like captions ready, hook into that event and run their own microservice and return a response. And we built it in a way that the workflow would wait up to, I think it was up to 2 minutes for all the different plugins that have hooked into that given event to return their given response. And if they don't return within 2 minutes, it just moves on. And if they return it, then that goes into a key value lookup for all the data that would respond. And then all of that will be available for the next event hook. And so what you had was this application that was originally just for live video streaming, that by the time 16 different developers had got their hands on it, it was using Gen AI to summarize what was said in the video and create titles, sharing it on social, working out if there was any like bad imagery in the videos, and all these interesting plugins that we never would have thought of on our own, right?
So let me ask you then, so why didn't you just build a monolith? I mean, you could have avoided all of that and said, here's the 16 developers, here's my GitHub repo, go at it. Like, why didn't you take that approach?
It's much easier to keep these things decoupled, so we thought, right? To say, here is the application, here's the bounds of the application. No matter what you build, it will always still work. Because what you build, even once we pull it into the app, the core app is separate, it's decoupled from that. And that was the most important thing. It couldn't break, it mustn't break, even if the extensions broke for any reason. So that was the main reason, right? We didn't want developers crawling all over the code base and us having to look at different GitHub issues if that one merges with that one, and what happens if they talk into the same database at the same time. We'll just use events, we'll just give you the event contract and you give us the response that it's supposed to return, and we'll publish that to our event catalog, and then other extension developers can see that and use that if they want as well, right?
Yeah.
And you had this nice decoupled way of growing your application.
I remember when you were building this, and often people think plugin architectures are for big projects, like you're building a browser or you're building a CMS or something where hundreds of thousands of users will be using it, and a plugin architecture is beyond them. But the actual amount of code you used was really tiny, and it made me think actually plugin architectures are much more applicable to many enterprise pieces of software.
Yeah, I think absolutely. And like even Stripe does a good example of this, where they have the ability to create something called Stripe apps, where Stripe's well known for having a great API and great documentation. The API can do loads of things, but many of those things might be something that the developers at Stripe might not know because they're not using the product every day to take payments and do all the things that it can do. So they created Stripe apps to allow other developers to build extensions that can even sit inside the Stripe dashboard that extend Stripe by using the Stripe API, or maybe it's just rendering different objects within your Stripe account, right? And it's that same piece of plugin and extensibility and allowing the developers out there to be able to bring their own specialists, their own skills, their own ideas without it affecting the core application.
Yeah, I mean, when we speak to enterprise developers, I think many are very competent in what they're doing. They've got knowledge of certain runtimes and certain pieces of software, but many of these concepts seem very new to them. So what would be your advice in terms of what's the best way to learn some of this stuff in terms of if I want to adopt extensions or plugins or any of the things you've been talking about? What should I start with first as an enterprise developer?
Just start with something small, something that is maybe not essential to the core business, right? Something with a small blast radius. If it goes wrong, if your implementation isn't good, it's okay. Like, you didn't break everything. Prove that champion that, and you can start to grow it from there. I think, if you build something that is useful, that is based on extensions, people will quickly realize the value that it brings, right? And you start to see customers grow their knowledge from there, I think.
Yeah. Now, you've been a developer advocate for 5 years, or it's coming on 6 years, I guess now, and I've worked with you that whole time. And I think you've been very successful because you've managed to convey complex concepts to people, especially people who are new in the software business and they're learning all of these things. So given all the demos you've made, what do you think are the important parts of producing a demo that captures the imagination of people so they can understand important concepts?
I think the first thing to try is to build a demo where people are using it without realizing they're using a demo. So they walk up to it, they go, oh, this is a thing that I can use to achieve something that I want right now. So whether that's ordering a cup of coffee or buying something from a store, different versions of this, they're straight away into your demo without really knowing that they're doing a demo. So that gives you the interest. After that, you want to build something that is using your product. It has to be obviously using the product, not something that is unrelated, not just some sort of grabby toy or something. It has to be something built with the product. And then there has to be an aha moment where they see something happen and they go, oh, okay, yeah, I sort of see how that's put together. And you can see that spark ideas in people instantly, and okay, this is a demo that is helping people to think of different ways they can implement something, right?
So when you're thinking about technology you can choose from, and the great thing today is that this is like a little sort of candy store of different places, the cloud providers and service providers. What's in your mind when you're choosing between the options that oftentimes are very similar? And how do you make a choice between I want to use this thing and not this thing?
Well, like I said before, a lot of the stuff that I'm building is fairly small use case, right? So one of the things I look for is a pay-per-use model, a kind of cloud approach model, something that will scale, often doesn't cost a lot in the beginning, and something that's got great documentation, right? And widely adopted already, I think are the key things. The other thing it has to have is an API. So you can customize it and you can extend it and kind of bend it to your will a little bit.
Yeah. So let's talk about APIs then, since that's a good point. So many people aren't sure what an API is. We talk about them all the time. But what do you think defines a good API? Just something that jumps out of you like, I can absolutely use this thing.
The first thing that I think of is great documentation. Yeah. So you instantly understand how to achieve the thing you want to do. Anything that you're able to do in a SaaS dashboard, you should be able to do with the API. It's really frustrating if you do a thing in the console or the dashboard and you can't achieve that same thing with the API. That, for me, that's like a little bit of a warning bell that what else can it not do that I might need further on. And then you need the authorization and authentication options that you need, and that could be different for different companies, right? You also want it to integrate well with the thing that you're building. So that could mean that service you're building has an integration with your cloud provider that maybe doesn't need you to stand up a webhook, for example. So you need to look beyond the API and see how does this service integrate with other things in the ecosystem that I'm currently building with.
Yeah.
Is there anything else you'd add? Like, how would you pick one?
I think that's a good answer. I was thinking about how then, again, you're going from this model where you're building something all yourself or on your own server or in your own environment, you're opening yourself up to all these other systems. I was thinking about testing and observability as two critical problems, because suddenly now you're not quite sure what's going on. And testing came to mind, and I just wondered, what are your thoughts around, I'm bringing in this API, how do I now test this API so that whatever I've built works with it properly and you can be sure that that's what you're expecting out of it?
Yeah, I mean, I can try and give you the correct answer, or I could just tell you what I do, which is probably not what you're supposed to do, right? Which is, I like test as you build. This is how I build things. Test as I build. I'm constantly clicking around different interfaces, different dashboards. So it's always useful when you come across a service that has like a single pane of glass that is showing all of the events that you're generating, all of the API calls you're making, all the errors, without you having to jump around different windows, right? That's a great thing to have. And surprising how many services don't start with that, actually. Local testing is also something that's really useful. I know that was a big issue for serverless for a long time. I suppose it still is, really. Although that's slightly different because that's more of a mindset of this concept of having a cloud account where every developer can test on their own cloud account and then migrate that into a UAT. But it's sometimes not realistic, is it?
All right. I think a lot of this also, scaling, to get to real scale on anything, you actually have to have a very good practice around testing.
Right. Because
there are these long tail issues that show up between services, and they don't show up until you hit a certain scale.
Yeah.
And it's really interesting because I've seen it both ways, where you don't build this in, and then when you get to a certain level of traffic, problems start to appear.
Sure.
And they become almost impossible to debug because you go through log files, you're trying to follow data across services, and it becomes fairly chaotic. Whereas when you do it the right way, it's much easier to set up an observability framework to how you want to approach things and then nail things down as they go wrong.
And this comes back to one of the reasons why workflows is a good way to build stuff, right? Because you have, on most of these services, you have that observability piece built into the execution of each workflow. So I think I kind of would cheat that a little bit by using a workflow service where it's sort of there for you in a nice package.
So let's go into that a little bit. So with step functions that you were using for these services, and you were also using other AWS services and things outside AWS, how did you trace transactions when something went wrong? If something was coming in through an API, ending up in a workflow, maybe going out to another provider to be processed and come back. What was your approach when there was an error to working out exactly where that went wrong?
Well, you would start with the workflow execution itself and have a look visually. Every execution would visually show you the state at which it broke. Now, sometimes it's not the workflow that breaks, it's some other piece because, like you said, it might have come from API gateway and then gone on to some other piece. Maybe your Lambda function is returning a 200 success, but actually downstream it's broken somewhere. So then you can add things like X-Ray, which is a nice tracing service on AWS, but I found that quite difficult to use, really, if I'm honest. But I think that's probably the best way of doing that if you want to stay within the AWS ecosystem. But then, there's services that are just specialists in these sort of problems, right? So I think as your application scale grows, you probably need to start using these other services where that's their expertise.
Thinking about things you've built in production in the last few jobs you've had though, and as they started to scale up and you've had a problem, when you couldn't fix something, often because it scaled up or you didn't build the right debugging, what was your approach to solving that problem? And you're in production, it's kind of chaotic when things start to go wrong that way. How did you approach dismantling a problem and fixing it?
I don't know, man. I probably go straight to the logs, and eventually you're in log hell, clicking around, trying to find that moment where you can see some sort of error. It's very difficult on these systems that are disparate, spread over multiple microservices that are running multiple cloud services that are maybe calling out to other third-party APIs. It's really a problem, right? And I think this is one of the reasons why you are starting to see a bit of a trend of people moving maybe a little bit away from microservices, or at least rebalancing the idea of using that for everything all the time, right? And I think this is probably the main reason is when your application is so decoupled and so spread out, what's actually holding it together,
Yeah. Well, I think over the last few years, the amount of data generated by these apps has just spiraled.
Yeah.
The first mobile apps I built, you hardly produce any data, and we're collecting a few log files. And before you know it, people are uploading photos, uploading videos,
Right.
It starts to explode. And so suddenly with that, your cost goes up enormously. And there's this trade-off of, it's great to have these cloud providers doing all these things for you, but when the bills start to arrive and you start to see how expensive it gets, it's easier often as a first cost-saving measure to bring things back a little bit.
That's totally true. It's a reason why, at these cloud conventions like, reInvent, some of the most subscribed to talks are stuff about optimizing for cost, right? Because when your application is built on services that you're having to pay for each time you use the service, you need to come up with all sorts of clever, interesting ways to reduce it and optimize for that.
Yeah, and I think this is one of the difficult trade-offs as a developer, because obviously in this toolbox, everything has been built practically that you could imagine using this library, this service, or you can build your own. And so the question is, when you build your own and you think about the developer hours and the testing and the maintenance, is it worth it versus buying something off the shelf or using something off the shelf and paying per use? And it really does vary, because where I came from before working at AWS, we were building for startups.
Yeah.
And one of the problems is, if you build for scale in a startup, that might not be the best use of your resources, because you don't know if the idea is going to work and people want to use it. But of course, you only find out if people want to use it when they all show up. And if you haven't built the scale in and your application falls over, they go somewhere else. And so there's this chicken and egg problem that buying the service off the shelf often helps with. And that's why I got into serverless when I first did. But then, of course, you get a bit locked in because you're with a vendor with one particular solution. And if then things scale up, you need to back out and move things. And I'm not sure there's a clean and elegant solution here, but to me as a developer, it means keeping your options open and knowing a broad spectrum of technology can really help you.
The best solution I'd seen for this is when you have these businesses where they maybe run most of their infrastructure on one provider, but they still have a little bit running in another, so that they understand the terminology, they have the relationship with the various teams in the other provider, and if they need to, they can shift, and they're not so locked in as if they had to start from scratch, right?
Yeah, it's one of the shames with the cloud, really, that you've got the big three, but there's so little commonality between the three.
Yeah, right.
And you look at something like Terraform, does a reasonable job of trying to abstract away, but in practice, if you want to even move buckets from one provider to another and data from one to another, the rules are all different, the limits are all different, the terminology is all different. And this lack of consistency between the three makes it very hard for developers.
I wonder if that's intentional, or if it's just small groups working together in isolation, or what, because a lot of these companies hire across each other. So I wonder what they do, and when you are an engineer that moves from one to the other, and all the terminology is slightly different, right? And
But when it was just simple before the cloud, when you had relational databases and compute and storage, but sort of various buckets of things. But now there's so many different things you have to deal with. I mean, even something like a queue, which in principle is very simple, the implementations across providers are very different. And so I do think it's something that, as you build, you have to think about to better keep your options open.
Yeah.
But it creates that cognitive burden on your teams, but to know how things work in different places.
Yeah, I think there's also a problem you have now where there's so many services, and they're all very similar. They have a lot of overlap and a little bit of something that's different. And we know you're not really encouraged to be super opinionated on the way you build things when you work for that company, right? Or you can be opinionated, but you can't make another service look inferior in any situation. Whereas in some situations, one thing is better to use than another. And so when you have a lack of opinionated guidance, it's really difficult for developers out there to know which thing to use on all the multiple versions of moving an event or a message around a system. Which is one of the things I like about having left a big cloud provider, is now we can just talk about the best of breed, right? We can take the best from here and the best from here and put them together, because that's probably what other developers and other customers are going to be doing as well.
Yeah, I say to a lot of junior developers who are new in the industry, when you start with these things, often you think that what you know, the tools you know, the language you know, are the way to build something. But in reality, as you start to accumulate more languages and more tools, you realize that everything's a trade-off.
Yeah.
There isn't so much a right answer and a wrong answer as just simply a decision you're making that will create debt in the future or work now.
Yeah.
And even just something as stark as, do you write a script on your laptop that does the work, or do you do it properly and break it out and put it in the cloud somewhere? That's a choice between work now, work later, and various distinct trade-offs. And it isn't so much about right and wrong. And that to me is the most fascinating part about building software, because everything I've ever built, I've made bad decisions.
Right. Yeah.
And those decisions come back to get you later.
Yeah. Actually, a guy asked me at the event earlier on today, what are the skill sets that you think are important for being successful as a developer advocate? Because it's often a role that people are interested in, right? So you've managed a couple of developer advocate teams now. What would you say are like important skill sets to develop?
I think it's one of the most difficult roles in technology to hire for.
Right, yeah.
Because it's an odd selection of skills. So first of all, you have to be a decent developer. You have to know certain runtimes, certain environments well, so you can talk about them with people.
Yeah.
You also need the ability to be empathetic with the users.
Yeah, that's important.
That it's not so much about right and wrong and the tech holy wars often you come across. It's really listen to people's problems, see if you know something that can help them. Also know when you can't help, because we just don't know that much in the space. I think you have to be a good communicator, whether that's something you can write, or you're good on video, you're good on the stage, you're good at getting an idea across to different people. And I think you also have to be fairly independent. You think about the teams we've been all over the world with our groups. You're in London, I'm in Denver, we've got people in Japan in our current team. So when you're by yourself, you have to know what you're doing and be willing to work on things. And you also have to be willing to put yourself out there and say, this is something I believe, but you're willing to be slightly wrong so the audience can engage. And often when I'm talking to people, they have some combination of these skills, but rarely all of them.
Yeah, it's back to that idea of being opinionated, right? And being brave enough to not necessarily learn in public, but have your way of doing things and to be able to explain that in a way that is reasonable, even if it's not the best way. I think that's always useful for people to be able to follow something that you've built from end to end and understand why you've made certain decisions along the way, right?
So let me ask you then, so you weren't a developer advocate before 5 or 6 years ago, and you've been doing this since then. What is it that you most like about being a developer advocate?
It's talking to people, I think, and constantly working on different projects, solving for different projects. I'm a problem solver. My wife hates me for it because you can't help but come up with a solution even when you should maybe just listen. And so you can do that in this job, right? You can constantly be hearing challenges and problems and thinking about ways to solve that. Maybe sometimes that's taking the problem up to the product team and they need to solve it, or maybe it's by explaining how you can use different things together and building a solution for it. But I think it's the personal aspect, the people aspect, the empathy that you need to be able to pinpoint a challenge and simplify a solution for that challenge. That's the interesting part for me. How about you?
Well, to me, I was training developer teams on serverless before I became a DA, because I had a company where we were building software.
Right. And
we had development teams in Colombia and Romania, and I picked up on serverless as being useful just because of the type of software we were building. And then I had to explain it to these groups about why it was useful, how to use it, and best practices. And then I got pinged by the AWS, did I want to do this as a living? And I found it was the best job in the world. I really absolutely love being a DA. And as you know, I've been managing the DA team for a few years now, but I think from a managing a team point of view, one of the great things is the personalities of DAs are all so distinct. And it's just extraordinary, the sorts of personalities who come into this role. So it's a true honor for me to be able to manage the team, because they're just such interesting people building different things.
Yeah, I think they're all the random nutters of the developer world. I really do. It's like a mishmash of odd bods, but it's great. It's nice. Yeah.
So my last question to you then. So obviously, as an industry, there's always new people coming in. They come in different ways these days, not just always through computer science degrees, through online courses, through trying things themselves. Yeah, as a piece of advice you could give, what's the single piece of advice you would give to people who are new and getting into things to get started and to really embrace the industry of software development?
I would say the most useful thing you could do is to share your learning. So every time you've understood a new thing, write about it, make a video about it, share it, some code that you've written on GitHub, and keep creating content around the problems that you're solving. And you'll find all sorts of interesting people reaching out to you to want to talk to you about that, because they're all meeting those same problems too. It's quite hard to do because you can look like a bit of a div sometimes, right? You've got to be honest about what you don't know and what you've just learned. But most people really enjoy that, don't they? What would you say?
Yeah, I think it's similar. I would say don't be afraid to experiment and get things wrong.
Yeah.
That even though software often seems very black and white, it's much more gray.
Right.
And you learn more by getting things wrong. I continuously still get things wrong when I build things, but every time I do that, I learn something that's insightful. And it's why I think the industry is still fresh and interesting after doing it for a couple of decades.
Yeah, absolutely. Constantly having to relearn every 2 or 3 years.
Yeah.
But it's what keeps it interesting, right?
It is,
yeah.
it is.
Yeah.
Well, thanks very much, Ben. This is Ben Smith, who's a developer advocate at Stripe. My name's James Beswick, and I run the developer advocacy team at Stripe. And this is GOTO Unscripted live from Chicago. Thanks for listening.